Imagine you're walking down your street in the middle of December. You see this massive oak tree, perfectly wrapped from the base of the trunk all the way up the branches in these really bright, intense LED holiday lights.
Oh, yeah. It looks completely magical, right? We all love seeing that.
Right, exactly. It's beautiful. But if you ask a plant biologist, or actually in the case of today's deep dive, a software engineer, they'll tell you that you're looking at a living organism being, well, slowly suffocated by perpetual daytime.
Yeah, it's pretty wild because we inherently accept that visual spectacle as just a harmless celebratory aesthetic.
Right.
People don't usually think about the biological reality happening beneath the bark. But when you apply a diagnostic framework to that glowing tree, it reveals this profound environmental stressor that fundamentally alters how the whole organism functions.
And uncovering that hidden stressor is exactly our mission today. We are exploring this really fascinating entry from a massive personal blog.
It really is massive.
Yeah, we're looking at a post titled Notes on Gardening, Part 838, Bright Lights, Tired Trees, which was actually published today, March 17, 2026, on keyandmeng.org.
I love that title.
Same. So the core mystery we're unraveling for you today is whether those beautiful nighttime LEDs actually damage the tree. And to get to the bottom of it, we're bridging this weird gap between software engineering, festive decorations, and the mechanical rules of plant biology.
And, the answer is definitive. But honestly, the path to that answer is what makes the source so compelling.
I totally agree.
The whole conclusion is entirely driven by the unique analytical framework of the author, the guy who asked the question in the first place.
Right. So the author goes by Ang, and in his site's bio, he describes himself simply as an old software plumber.
I love that phrase. Software plumber.
It's great. He basically spends his nights tinkering with free, Libre, and open source software, or FlawSS. He's working with these super complex system-level programming languages like Elixir, Python, and Rust.
And he treats his physical environment, so his garden, his fish tanks, his daily routine, with the exact same debugging mindset he uses for code.
Yeah.
And the metadata of this blog, it really paints a clear picture of how Ang's mind operates. He documents everything with the rigor of an open source project.
It's honestly staggering.
Just look at the sidebar data. This post is part 838 just on gardening.
That's insane.
Right. He also writes about Haskell programming up to part 84. Fish keeping is at part 209, dieting. And in 2025 alone, Ang published exactly 730 posts.
Wait, 730?
Doing 2 posts a day, every single day, meticulously logging observations.
That is just a massive amount of output. But I think, more importantly, it shows you how he views the world.
If we connect this to the bigger picture, it explains exactly why this matters.
Right.
A programmer looks at a piece of software as a system of interconnected logic. If a program crashes or slows down, they don't just guess what's wrong. They isolate the variables, find the anomaly, and research the root cause.
And Ang is basically applying their exact diagnostic eye to the natural world.
Exactly. He's a plumber of systems, whether the pipes are carrying data or, in this case, plant nutrients.
Yeah, so over 700 posts a year of pure system-level debugging kind of explains why a simple walk around the block led him to diagnose a decorative neighborhood tree like it was a glitching server.
He's constantly scanning his environment for inputs that just don't match the expected outputs.
Which brings us to the specific incident that sparked this whole deep dive. Ang writes that he's out taking a stroll through his neighborhood during a festive season, and he specifically notes an environmental detail that I think sets the stage perfectly.
Oh, the heat wave.
Yes. He mentions he's trying to cool down during a heat wave.
And that environmental tension is vital context here. A heat wave is a massive biological stressor for a plant.
Right, it's already struggling.
Exactly. The tree's already operating in a state of high alert, expending its water and energy reserves just to survive the extreme daytime temperatures. So it desperately needs the night to recover.
Okay, let's unpack this. So he's walking in this heat wave, and he stumbles upon this tree. He takes a photo of it for the blog. The trunk, the branches, everything is tightly wrapped in these decorative lights.
And most people just walk by and admire the glow.
Yeah, but Ang looks at this setup and sees an anomaly in the system. So he asks this very direct diagnostic question, which is, would this actually damage the tree?
It is the ultimate root cause analysis question. Is the core system, the biological machinery of the tree, being degraded by this external input?
And he does the research to find the biological reality.
He does, and the answer is yes. Wrapping a tree in intense lights and leaving them on all night seriously disrupts its photoperiod.
Right, the photoperiod. I was trying to make sense of this concept based on the reading. From what I gather, it's basically because plants don't have a central nervous system, right? Or like eyes that get heavy when they're tired.
Right, they don't sleep like we do.
So they rely entirely on the mechanical external cycle of light and dark. It acts as an evolutionary clock.
Precisely. Plants evolved on a rotating planet. For hundreds of millions of years, their entire biological development has been predicated on the reliable, predictable transition from day to night.
They just assume the sun will go down.
Exactly. Their DNA assumes that the sun will set. That photoperiod dictates every critical life function they have. It tells them when to open their stomata to breathe, when to flower, when to drop fruit, and, most importantly, when to trigger their recovery systems.
So by introducing artificial LEDs and just leaving them plugged in all night, we're basically hijacking that evolutionary clock.
We are overriding the environmental cue it needs to survive. We're forcing it into a perpetual daytime.
And the text points out that creating this perpetual daytime prevents the tree from utilizing the darkness to repair itself.
Yes.
I really wanted to visualize how this actually functions on a cellular level inside the tree. And the best way I could picture it was like a massive manufacturing business.
Okay, I like where this is going.
Right, so imagine the plant is a factory. The daytime shift at this factory has one singular job, manufacturing the product.
Which is sugar.
Right. They use sunlight to aggressively manufacture sugars through photosynthesis. That daytime shift is purely focused on production.
Right.
But the night shift at this factory doesn't manufacture anything. The night shift is the logistics and maintenance team. Their job is to take all those sugars manufactured during the day, pack them up, and actually ship them to the warehouses where they're needed, while also repairing the factory floor.
That analogy maps perfectly onto the biological mechanism Eng researches, which is called respiration.
Respiration, right.
Nighttime is when plant respiration peaks.
So if photosynthesis is the manufacturing shift, respiration is the logistics shift, how does that logistics network actually operate? Because, I mean, those sugars can't just teleport from the leaves to the roots.
No, they definitely can't. So during the day, the leaves become packed with newly synthesized sugars. But sugars just sitting in a leaf don't help the roots grow deeper, and they don't help a broken branch heal.
Right, they have to move.
Exactly. During respiration in the darkness, the plant expends energy to actively transport those sugars through its vascular system, specifically something called the phloem.
The phloem, okay.
Yeah, it moves them down into the root system for long-term storage and up into the new shoots for physical repair and growth. It's a highly active, physically demanding process that actually requires the absence of light to function optimally.
So if the logistics shift only clocks in when the lights go out, wrapping the tree in LEDs means the logistics team never gets the signal to start working.
Exactly. The daytime manufacturing shift is forced to work around the clock. They just keep pulling in whatever light they can, trying to manufacture more product.
So the factory floor just completely overflows with sugars in the leaves, but nothing ever gets shipped out.
Yep.
The roots starve
Yeah.
because they aren't getting the shipments.
Yeah.
And the damaged tissue, like from that heat wave we mentioned earlier, never gets repaired because the maintenance crew literally never clocked in.
The entire internal supply chain is paralyzed. And Eng states plainly what the consequence of that paralysis is. The tree cannot allocate its resources effectively. It becomes structurally exhausted by endless light.
Because you're suffocating the tree's internal logistics by taking away its darkness.
Precisely. The visual of the bright festive tree is actually hiding a biological system that is quietly collapsing under the weight of its own unallocated resources.
That feels completely counterintuitive to everything we learned about plants in grade school, though.
How so?
Well, the basic equation we're taught is always, sunlight equals plant food. Light equals life and growth. That really made me question the premise when I was first reading through Eng's notes.
It's a very common assumption. If some light is good, maximum light must be optimal.
Right. If light is energy and energy fuels growth, it seems like we should be exploiting that in commercial agriculture. Think about a massive commercial indoor vegetable farm. The operators control the environment entirely. They have millions of dollars invested in hydroponics, HVAC systems, real estate. The economic logic of capitalism says you run the machines 24/7 to get the maximum return on your investment. If I want my lettuce to grow twice as fast, shouldn't I just blast those crops with intense growth lights around the clock? Just force feed them light to accelerate the harvest?
Well, what's fascinating here is that Eng explicitly raises this exact question in his post. He writes, let me see. While drafting this, another question came to mind. Does indoor farming also expose vegetables to growth lights for 24 hours?
Yeah, because if constant input breaks a neighborhood tree, do we intentionally use constant input to optimize a commercial vegetable system?
Exactly. But he found out that commercial indoor farms do not use 24-hour light.
Wait, really? I totally assumed industrial farming would push those limits.
You'd think so, but biological limits supersede economic desires. Even the most highly optimized indoor farms typically follow a strict schedule of 16 hours of light on and 8 hours of light off.
Wow. So if 16 hours on and 8 hours off is the golden ratio for high-yield farms, that must mean the plant physically stops processing light after hour 16. Like it hits a wall where more light no longer equals more growth.
You have just described the daily light integral, or the DLI.
The daily light integral.
Yes. Eng tags his post with this specific term because it's the fundamental metric of plant biology in this context. The daily light integral dictates that plants have a hard biological saturation point.
So a biological saturation point basically means the factory can only process so much raw material in a single day, regardless of how much you supply to it.
That's a great way to put it. The enzymes responsible for photosynthesis can only work at a certain rate. Once a plant is exposed to 16 to 18 hours of continuous light, its system just maxes out. Now, different crops have different specific DLIs, like leafy greens might max out slightly earlier than fruiting plants like tomatoes, but they all share this fundamental trait. The photosynthetic machinery reaches its absolute maximum capacity.
So pouring more light onto the plant after it reaches its DLI does absolutely nothing to increase production.
Nothing at all. Which makes Eng's analogy in the text so perfect. For someone who tinkers with electronics and open source software projects all night, his brain naturally goes to hardware.
Oh, the battery analogy.
Yes. He says to think of the plant under a light like a battery.
It is a phenomenal way to conceptualize a biological threshold.
Right.
Because if you have a rechargeable battery that is fully charged at 100% and you keep it plugged into the wall, you don't magically get a super battery that holds 150% power.
Exactly. The extra electricity doesn't give you more capacity.
Right. When you overcharge a battery, you actually degrade the cells. You actively damage the hardware by forcing energy into a system that has no capacity to store it.
And a plant is biological hardware. When you push it past its daily light integral, when you blast it with light past that limit, you're no longer feeding it. You are bombarding its cells with radiation they cannot process. You are degrading the hardware.
Man, it fundamentally changes how you look at those festive lights.
It really does.
You aren't just decorating a tree. You're plugging a biological battery into a charger and leaving it there for a month straight, slowly degrading its ability to function. The tree's basically trapped, unable to shut off its receivers, taking cellular damage night after night.
And this brings us to the core takeaway Eng wants his readers to internalize about systems. He notes that understanding these biological fundamentals is what separates someone who just buys a plant from a true gardener.
Yeah, because a casual buyer just sticks a plant in a window and hopes for the best.
Right, they just add water.
But a true gardener, much like a good software engineer, understands the invisible systems at play. They understand the photoperiod. They respect the daily light integral. They know that the absence of a thing, in this case, the absence of light, is just as critical as the presence of it.
It all comes back to respecting the limits of the system you're interacting with. Eng respects the code he writes, he respects the parameters of his environment, and he respects the biological limits of the plants he observes. Yeah.
He recognizes that every system requires a down state to maintain its integrity.
So what does this all mean? When we pull all these observations together, from Eng's walk during the heat wave to the mechanics of respiration and the hard limits of the daily light integral, the ultimate insight for you, listening to this right now, is a fundamental reevaluation of how we view energy and recovery.
Absolutely.
Whether it's a giant neighborhood street tree wrapped tightly in holiday LEDs or a highly optimized indoor vegetable farm trying to grow food, the rule remains absolute across the board. More input does not equal more health.
No, it doesn't.
Darkness and the biological recovery that happens within that darkness are not optional. They are mandatory.
Without the night, the logistics of survival completely break down. The system just fails.
Which brings up a thought that I really want you to mull over today. We've spent this time looking at the world through Eng's incredibly analytical eyes. He tracks his entire life across thousands of posts. He understands the exact limits of the systems he observes.
He knows a plant's daily light integral, and he knows that after 16 hours, Extra input becomes actively damaging rather than productive.
He recognizes that saturation point where the hardware begins to degrade.
Yeah, and it makes you wonder if plants have a hard biological limit where constant, unrelenting input literally damages their cells. Do we as humans have our own internal daily light integral?
Oh, that's an interesting thought.
Right. But instead of light, think about information. Think about constant digital stimulation. Think about the notifications, the screens, the endless scroll of data we process every single day. Are we constantly pushing our own systems past our psychological saturation point?
It's a deeply relevant parallel. Are we forcing our own minds into a state of perpetual daytime where the influx of information never actually stops?
Exactly. Are we forgetting to give ourselves the darkness required to process and repair? Because just like the tree can't move its sugars to its roots without the night shift, maybe we can't move our daily experiences into long-term memory or emotional stability without unplugging and stepping into the dark.
Wow. Yeah, it's something worth pursuing further, as Ang would say, a vital piece of self-diagnostic debugging for all of us.
I couldn't agree more. Well, I want to thank you so much for joining us on this deep dive into the fascinating, incredibly well-documented world of qianmeng.org. The next time you walk down a street during the holidays and see a tree wrapped perfectly, sparkling with bright, intense LEDs, you might just find yourself hoping someone remembers to pull the plug, just for a little while, to let the night shift do its work. Take care, everyone.